Hello everyone, welcome to the first session of the second week of the Introduction to Modern Application Development course. Let's begin by reviewing the design considerations for a command line application that we have seen previously. This will be a more intense review, and after that we will go on to look at the implementation of the actual command line solution. This of course will be an illustrative example. It's an implementation that is meant to illustrate how the command line should work. Let us start with a question. For a command line application, when do you think it is suitable to use a interactive style, or when is it suitable to use a non-interactive style? We have seen what is meant by an interactive approach versus a non-interactive approach for a command line. To recap, an interactive approach is the one when the information required for the program is made available after the program starts running. In contrast, in a non-interactive application, all the information that is required for execution must be supplied before the program begins execution. You should write down your own lists of points about the advantages and disadvantages, or whatever you think about interactive style versus non-interactive style. Further, we encourage you to discuss this on the forums for this course. Here is another task for you. Trace the evolution of the idea of an executing program from its early beginnings. Computing machines have come up since around 1945, but in those days, programming a computer meant connecting the wires and the switches. So the idea of an executing program was quite different in those days. Over the decades, the idea has evolved to the present day. We encourage you to look up this idea, trace it up. Maybe you could divide the entire period into decades, say 1945 to 55, 1955 to 65, 1965 to 75, and so on until the present day. This would be a very interesting this would be an interesting idea in itself, and will give us some foundation to understand the way this course has been designed. Professor Sane has used a non-interactive approach when he illustrated the problem of fair share. Recall that there are three modes in which we expect the fair share application to run. On your screen, you see the slides which we had used before. One of the modes is registration mode, in which all the roommates register their names to the application. This allows the application to recognize the correct roommates in the future. The main workhorse of the application, of course, is the expenses recording phase, when the application records the expenses for an event by a roommate. We had seen that the registration phase would be simply a loop running over all the names given on the command line, and the expenses phase would be simply calculating the per head share given the amount for each roommate. Finally, the report generation part is also finally report generation would simply involve accepting the name of the roommate whose report is to be generated. Recall that this is a design decision for us. We have decided that we would be generating report for one and only one roommate. There are other choices that we had seen before, but we choose not to use any of them. Here is the block diagram of our proposed command line application. The red outline encloses the functionality of our application. The input comes from a terminal. For us, it is the keyboard. The output is on the monitor, the video monitor. Together, this is the terminal. The block diagrams represent the functionality that we expect, that we need, that we require in the application. We had seen that one phase would be to convert all the input to appropriate data types within the programming language. Once these are available as suitable data types in our programming language, then we can perform further processing. We had also seen the processing that would be required. The basic calculations, the idea has been fairly simple. In fact, we have also illustrated it using a spreadsheet. You could also try it out just using pencil and paper. The simplicity of the solution also allowed us to think about the correctness. Our reasoning tells us that our approach will work whatever be the number of roommates. At least in principle, it is guaranteed to work. In practice, of course, we will have limitations because of implementation and many other restrictions. But our algorithmic approach is correct. Finally, the information that has been calculated or whatever information is required has to be displayed on the output device. That would also require conversion from the internal form within the language and what is required for the output device. Remember that we had suggested that for input as well as the output conversion parts, please try to use the facilities that your given programming language offers you. In our case, it is Java, so we would be using the facilities for input and output conversions that Java provides. Finally, there is one more block over here, the data storage on secondary memory. We will come to that a little later. This slide helps us to recall the ideas behind the command line approach. Let us go ahead and actually look at a terminal interaction about this. Here is a standard Windows terminal whose prompt we have set as $, and our cursor is blinking at the prompt. Our program is here. The way to build this program is to use the Java compiler and compile this Java program to a class file. Normally, the Java compiler would be available as simply as the Java C command because it would be in your path. But we chose to illustrate the entire command line for your clarity. If the compilation is successful, then all that happens is that we arrive back at the prompt. In case there are errors, then the compiler prints those errors before giving us the prompt for the next command. Once the program runs, once the program successfully compiles, we can of course run it, but we need to run it on the Java virtual machine. This is done using the Java command. Oops! We forgot that our command actually requires other parameters. Also, it also shows us that we have not really written the command, our program, in as nice way as required. This error that you see also shows us that the program that we wrote for the fair share application is not yet fully complete. In fact, a well-written program should not show such an error. Instead, it should tell the user, offer a brief help message, guide the user about the correct way of using this program. Nevertheless, let us continue. Let us register few roommates. I will use the names of my colleagues at Persistent Computing Institute. Five friends. We register, and here is what our program tells us. It has registered 5 roommates. We can now add the expenses for various events that all of these people indulge in. Let us suppose that Amod is the first one to pay, say, 100 rupees for some event that has occurred, that all 5 of them have shared. We record this using this command. Okay, the command tells us that there is some database in a file called fileshare.dat. It tells us that this file exists. It tells us how many bytes it is so far consuming. The number of events found is 0. And the number of roommates found is 5. Finally, it tells us that the event with expense 100 by Amod has also been added. Let us add other expenses by other members of this group. Let's suppose in the second event I spend rupees 100. I contribute rupees 100 for the entire group of roommates. Similar to the display above, our program again tells us the name of the file of the database, whether it exists or not. But notice that the number of bytes in the program, the number of bytes in the file have changed. That's because new information has been added in this run of the program. It is important to realize that when the program ran for updating Amod's expense, that run of that program is different, completely disconnected from the run in which my expense have been recorded. These are two different runs of the same program. Let us go ahead and add the expenses by others. Let us say Anuradha spends 100 rupees again, and our program adds that up. Remembers that information. Then Rustam pays. We have a few interactions with the program that recorded expenses. If you observe, say, the number of events found information, you will realize that the information that is counted actually starts from 0. That is why when the first expense was recorded, it said that the event was 0. A well-written program should really be informing that the first event would be 1, not 0. Most programmers are comfortable with starting from 0, but typical users would be very confused if your program said that the number of events is 0. They would be very confused because they are using this application to say that the first event when Amod paid 100 is to be recorded, and this program is saying it is 0. Only after a couple of runs do we realize that our program has been written such that the events are numbered from 0 and not 1. Let's check this out. Let's have Shekhar contribute 100 rupees again. This is the 5th event because we have actually had 100 rupee contributions for 5 events by each individual member of Persistent Computing Institute. The number of events is shown to be 4. The number of roommates is correctly displayed as 5. We should really be writing programs such that our users understand the results, the output, the information that is being displayed. What we have done so far is 5 events where 5 members of the group have equally contributed. This means that after 5 events, nobody really owes anything to others. Let us check if our program really reports exactly that case. So if, for example, I ask our program to tell me what is the final amount that I owe, it says 0, which is correct. If I ask about, say, Amod, again that is 0. If I ask for Anuradha, that is 0 too. But let us now suppose that we have the 6th event where Shekhar spends 200 rupees for the group. Let us now ask again, how much does Abhijat owe? It should be 40 rupees. Awesome. The answer that is shown is exactly 40. But again, if you notice very carefully, there is a slight problem. Just like the events that were numbered from 0 would be confusing to the user, a number like minus 40 is confusing, particularly when the comment before that number says the amount owed to others is minus 40. Let me illustrate the problem by looking at Shekhar's report. Shekhar has contributed more, so he should actually be receiving from others. Note the way the program responds. It says amount to be received from others is 160 rupees. This makes sense to the end user. However, if the end user sees that the amount owed to others is minus 40, then that can be confusing. What we are talking here is we need to be displaying information in a consistent form for the end user. Recall, the reason why it is minus 40 is because in our program, within the program, we chose to represent the amount that is to be paid by negative numbers and the amount to be received by positive numbers. But this is really an internal affair, something that is internal to the program. This ideally should not have anything to do with the user. Either we should inform the user that look, negative numbers means that you owe money and positive numbers means that you will receive money. We should inform the user about this convention before we even display like this. Or we should convert the negative numbers to positive numbers and then we can say the amount owed to the others is 40 rupees. There is a certain element of design, the way the program output should interact with the user, even if it is a non-interactive program. Well, this illustrates the way in which our program runs. Instead of looking at this slide, we chose to show you how exactly the application would be built. It's a simple command that compiles a Java program to its corresponding executable format called as a class file. We showed by explicitly running the program that the executing program accepts some data to process and produces the result. It also illustrates the actual ideas in the previous sessions where we talked about the fact that for any program, some input would be required and there are a number of input mechanisms for this. Similarly, a program would generate some output and there would be a number of mechanisms for collecting this output. Also, for the command line, we chose that the input device would be the keyboard, which is what we did by actually typing the commands on the keyboard. And the output device was a text-based terminal, your video monitor. Actually, in our case, it was a Windows terminal application. You can look that application up by searching for command prompt on your Windows system. This slide summarizes what we have seen so far. We will now go ahead and look at the actual Java program and try to connect it up with the various block diagrams that we had seen before. Let's try to look at the first part of the story, registering the roommates. We saw that registering the roommates is simply running a loop until all the roommates are registered. This was the idea that we had thought. Let us look at the source code of the command that we had just seen. Instead of using the terminal, it might be a good idea to introduce an editor for this purpose. Here is our Java source code of the program. Like a typical Java program, it starts by doing some imports of Java functionalities that we would need. Then there is a single class fair share, and the entire program is contained within this class. As you very well know, a Java program starts with a static main, a public method, static method called main, which is here. In this has only two parts: do the setup and process command line. Let's go to processing the command line. As you can see, the process command line function is a pretty small one. In fact, the only thing it does is it looks at whether the args variable has the value register, or has the value expense, or has the value report, and depending on the value it calls the corresponding method. If the arg value is register by ignoring case, then it calls the method to do registration. If it is expense, then it calls do expenses. If it is report, then it calls do report. The command line processing function is just basically a dispatcher. Depending on what is there on the command line, it dispatches the corresponding method. How does it get access to the command line? It gets access to the command line through this variable. This is a parameter which represents the command line that we type on our terminal. How does this command line information arrive for this process command line method? Well, that arrives through the main. Notice that the main itself takes parameter args. This has been defined to represent the command line for a Java program. This is a Java standard. So whatever you type on the command line, within your program it is available to this function main as a parameter. And within our program, we see that all that main does is passes the parameter args. It passes the parameter args to the process command line function. For the moment, we will ignore this do setup function. We will eventually at some point look at what it does. Let's focus on process command line and go ahead. Okay. Having seen how the information from the command line arrives at the process command line function, we see that the process command line function is just going to look at the first value of the arguments array, store it in mode, and use that. If the mode string is the same as register, then dispatch this method. Also note that the command line arguments are passed to this method. If the mode, that is the first string on the command line, is expense, then dispatch the do expense method and also pass the current entire command line to the do expense method also. Just like main passed it to process command line passes it ahead to do registration or do expenses or do reports, as the case may be. Observe this. So process command line acts more like a dispatcher by looking at what is the operation, the user command that has been requested. If the user command is register, then perform the do registration operation. If the user command is expense, then perform do expense recording. If the user command is report, then generate the report for the user that has been specified. Let us look at do registration. The do registration method first calculates the number of roommates. The number of roommates is simply the number of command line arguments minus 1. How is the command line specified for registration? It says fair share register. It's fair share register Amod, Abhijat, Anuradha, Rustam and Shekhar. So if we skip the first keyword register, then the next 5 are the names of the roommates. So if the number of words on the command line is x, then x minus 1 is the number of roommates if the first word is registration. That is how the program first calculates the number of roommates. Once the number of roommates are done, it simply creates a database and registers them. We will come to the creation of the database a little while later. In the meanwhile, let us look at register new roommates. Recall that when a registration occurs, it is a fresh start. There is no data, there are no events, there is no expense done so far, and the only thing that is done is that the information about who are the roommates is collected. Let us represent this information as a header line in our database. So the register roommate method just creates such a header and writes it into the file. That is all that register roommate does. We will come back to the details of this database and files and so on and so forth in a little while. But we just wanted to illustrate the operation of the do registration function. Let us now go ahead and look at the next part, which is do expense. Okay. Remember that the do expense command line involves the expense keyword, the name of the roommate who has spent the money, and the amount of money that is being spent. All of this information is available on the command line, and therefore the do expense method is programmed to accept the command line. And we have already seen that the command line is passed from main to process command line and process command line to do expense. The first argument of the command line is the name of the person who has spent, and the second argument is the amount spent. The do expense method is the first point where we now need to convert something that is in string form to something that in an internal form for our program. The amount of money that is paid by this particular roommate is a string of characters on the command line. So when Amod spent 100 rupees, what you typed as 100 is actually just a bunch of characters 100. This string of characters has to be converted to the numerical value 100. This is the phase of conversion from input to a form that is used within a programming language that we had seen earlier. In this case, it appears to be just one statement. So all it does is the string representation is converted to the double value and stored in a variable e. Now the do expense method calls another method add event. We will shortly see what it does. Just like the do registration method had created a header record, the do expense method creates a expense record. And then again writes it into the database. The do registration method deletes any earlier database and creates a fresh new database, whereas the do expense method must always add to the current database. Let us look at what add event does. The add event method first obtains the index of the roommate. This is another example of conversion, but it is slightly subtle. The name of the roommate who paid has arrived as a parameter by to the method add event. The name is a string. But what we need to do is to obtain the index into the array of the roommates. That is what is performed by the getIndex function. It takes the name of the roommate and returns the returns the index into the roommate IDs array. At this point, I would like you to recall that a few sessions ago we talked of the difference between input output and parameter passing and return values. Here is an example of the getIndex method, or function if you will, which accepts the string name parameter and returns the index as a return value. Once we obtain the index of the particular roommate, then we now wish to calculate who has spent how much and what is the per head share. In order to that is done in this part of the program. We run a loop over all the roommates, and if the ith index is the same as the roommate who has paid, then we update the amount at that particular index, or it is 0. So we have an array which has as many elements as the number of roommates, and for all the roommates except the one who has paid, the contents are 0. For the roommate who has paid, the contents are the amount of the money that has been paid. The add event method then goes on to compute the fair share. What is the fair share? Well, this is the point where we divide the amount that has been paid equally amongst all the others. This method has been illustrated before. Let us see how it has been implemented. The compute fair share simply calculates the per head share, and if the room, and then it updates the per head share array for every roommate. How is that update done? If the current roommate is the same as the one who has paid, then the value is the amount that that roommate has paid minus his or her per head share. If it is any other roommate, then it is the per head share. A small digression. We hope you understand this syntax. This is what is called as a ternary operator, and the way it operates is, if this boolean is true, then return this value. If the boolean is false, then return this value. This is called as a if expression or a conditional expression, and this is different from a conditional statement, which is normally what we see, the if statement in our programming languages. Here is another way of doing the same calculations. The amount was already recorded in the money spent. The money spent is either 0 or it is the amount that has been spent. And from everyone's individual money spent value, you simply deduct the per head share. Also observe that compute fair share calculates the program invariant. This is what the do expense method did. we saw that the add event actually just computed just first recorded the money that was spent and then computed the per head share. Having done that, a record was created and written to the database. That is all do expense does. Let us look at do report finally. What would reporting involve? Reporting would simply first take up the name of the person whose report is required. Again, this comes from the command line. From the command line that we type to the argument args of main. The main passes args to process command line. The process command line dispatches the corresponding method and also passes args to that method. That is how arg comes to the command line information arrives at do report. As far as the reporting for one single individual is concerned, conceptually it's a very simple idea. If we use the image of the spreadsheet where events are rows and individuals are columns, then reporting for an individual, the final amount, is simply adding the contributions or debts for that individual across all the events. For every event, whatever this individual has contributed or not contributed, that is to be added, and the final number is what is to be reported. That is all. So it starts with initializing the amount to report as 0 and just goes on adding up, just adds the per head share. This is all there is to the program. This has been a fairly intensive session, and this is a good time to pause. We will continue in the next session with what would it mean to remember information. We had in this session skipped the ideas about creating a database, updating it. We had just sort of mentioned it in the passing. In the next session, we will focus on these. See you then.